Hello friends, in this video link we will study about in chapter units and measurement. The heading is measurement of inertial mass. Measurement of inertial mass. The inertial mass of a body is measured by the inertial mass of a body is measured by using a device called inertial balance It consists a long strip of metal. It consists a long strip of metal. One end of strip is clamped to a table. One end of strip is clamped to a table. The other end of strip carries a pen in which body whose inertial mass a pen in which body whose inertial mass is measured is kept. When the strip vibrates horizontally, its inertia comes into play. And not the force of gravity of the earth. It is found that period of vibration capital T is directly proportional to the square root of inertial mass. Of the body. Thus capital T proportional to root m, or capital T square proportional to m. Let m1 and m2 be the inertial masses of two objects. Inertial masses of the two objects and T1 and T2 and T1 and T2 are their corresponding periods of vibration. Their corresponding periods of vibrations. Then m2 upon m1 equal T2 square upon T1 square. T2 square upon T1 square. This is the mathematical expression for calculating the inertial masses. Measurement of gravitational mass. Next heading is measurement of gravitational mass by using physical balance. By using physical balance. The physical balance works on the principle of moments. A physical balance works on the principle of moments. That is when an object is balanced. When an object is balanced under the action of several forces. Under the action of several forces acting in the same plane. Acting in the same plane, the sum of the clockwise moments, the sum of clockwise moments is equal to sum of anti-clockwise moments. Is equal to sum of anti-clockwise moments. The object is to be weighted. The object is to be weighted, is placed in the left pan, is placed in the left pan, and the standard weights are placed, and the standard weight placed in the right pile. The weights are adjusted. The weights are adjusted till the beam becomes horizontal. Now friends, we will define the dimensions of a physical quantity. Dimensions of a physical quantity. Dimensions of a physical quantity. Seven dimensions of the world. Seven dimensions of the world. All the derived physical quantities can be expressed in terms of some combination of seven fundamental or base quantities. All the derived quantities expressed in terms of seven physical units are in terms of some basic physical quantities. We call these fundamental quantities as we call these fundamental quantities as the seven dimensions of the world. Seven dimensions of the world, which are denoted with square brackets, which are denoted with square brackets. Dimension of length equal to L. Dimension of length equal to L. Dimension of mass. Dimension of mass equal capital M. Dimension of time equal capital T. Dimension of electric current. Dimension of electric current. A. Dimension of thermodynamic temperature. Dimension of thermodynamic temperature. Capital K. Dimension of luminous intensity. Dimensions of luminous intensity equal CD CEJ small, and dimension of amount of substance. Dimensions of amount of substance mole. Our next heading is dimensions of a physical quantity. Dimensions of a physical quantity. The dimension of a physical quantity are the dimensions of a physical quantity are the powers to which are exponent to which fundamental quantities must be raised. The fundamental quantities must be raised to represent that quantity. To represent that quantity completely. For example, density equal mass upon volume, or it becomes mass upon length into breadth into height. The mass capital M upon L cube, it becomes M L power minus 3, and in MK system it becomes ML3 T 0. Now friends, we will see different types of variables and constant. Different types of variables and constant. Different kinds of variables and constant. On the basis of dimensions, on the basis of dimensions, we can classify quantities into 4 categories. We can classify quantities into 4 categories. Number first, dimensional variables. Dimensional variables. The physical quantities which possess dimension. The physical quantity which possess dimension and have variable values and have variable values called dimensional variables, called dimensional variable. Example, area, volume, velocity, force. Example, area, volume, velocity and force. Second one is dimensionless variable. Dimensionless variables. The physical quantities which have no dimensions. The physical quantities which have no dimensions called dimensionless variables. Its example are angle, specific gravity. Angle, specific gravity and strain. Third is dimensional constant. Dimensional constant. Physical quantities which possess dimension. The physical quantities which possess dimensions and have constant values and have constant values. For example, gravitational constant, gravitational constant Planck's constant, etc. The fourth one is dimension less constant. Dimension less constant. For example, pi and e, its pi and e, etc. Applications of dimensional analysis. Applications of dimensional analysis. To convert a physical quantity from one system to another system. Second one is to check the correctness of a given physical quantity. And number third is to derive a relationship between different physical quantities. That is very important topic. Now we will see conversion of one system of units into another units. So friends, in my next video link, we will see conversion of one system of units into another units, and we use the formula n1u1 equal to n2u2 and some related numerical problems. So friends, please wait for my next video links. Thanks.